All right, hello Algebra 2. This is our first target. We did a little bit yesterday, but that's all right. I'm going to record the entire thing so we have the whole thing. We are going to work on our first target. It is called LFR1 for Linear Functions and Relations 1. We're going to be doing slope and rate of change. The target is called I can determine and interpret slope and rate of change. So through the magic of this business, here we go. I'm going to hop to the other computer, the board, and 3, 2, 1. Ta-da! Here I am. All right, fantastic. And I forgot my pen anyway. Okay, let's do the thing. Okay, slope and rate of change. This is the 5.31. I can determine LFR1. I can determine and interpret whoa, slope and rate of change. Okay, there we go. I can determine and interpret slope and rate of change. So let's go ahead. Let's go ahead and take a look at what all this is meaning. So determining rates of change. For a function defined in terms of x and y, the rate of change, if you see highlighted words or bold words, probably some emphasis in here, the rate of change over a part of the domain, x values, I'll give you that one, it's early in the year. X values of the function is a ratio that compares the change in y to the change in x in part of the domain. Now, you've seen this before. You've seen slope, you've seen rate of change stuff. I want to make sure we understand it and we can apply it. All right? Rate of change is the change in y compared to the change in x. So we got this table. It shows the year and the cost of sending 1 ounce letters in cents. Let's look at the changes here from 2003 to 2004. So in 2004, it was 37 cents. And in 2003, it was 37 cents. So if I change that, the top 37 minus 37 is 0. And 0 divided by 1 is just 0 cents per year. There was no change between those two time periods, right? Let's go from 2004 to 2006. So in 2006, our table tells us it was 39 cents. So it goes to 39 cents from 37 cents, which means it's gone 2 cents. It's increased by 2 cents over the course of 2 years. We can simplify 2 over 2 to 1 over 1 or just 1. So the average increase between those 2 years is 1 cent per year, if you look at it as an average. From 2006 to 2008, we have 42 cents in 2008, so 42 cents compared to 39 cents. That went up 3 cents over 2 years, or this hurts. This hurts, but decimals, right? We can do it because it's money. 1.5 cents per year was the increase. Okay? From 2008 to 2013, in 2013, the rate changed to 46 cents. So from 46 cents, that was 46 cents from 42 cents. So it increased 4 cents over the course of 5 years. If we take and make that a decimal, that ends up being 0.8 of a cent per year. So we've got these different time points, so we've been looking at them. All right. What does all that mean? Let's go to the next page here. Plot the points represented in the table. Connect the points with line segments to make a statistical line graph. So let's double check here. Double check my numbers. 37, so 337, 437. 337, 437, and then 639, 842, and 13 was 46. So I've labeled my points. I'm going to connect my points with line segments. Okay. Connected my points with line segments. They're not great. They're not perfect, but I do the best I can. Let's do this. Find the rate of change for each time period using the graph. We did that. The rise and the run. Label the vertical increase, the rise, and the horizontal increase or run between the points 437 and 639. So between 437 and 639, it rises 2 cents because it goes from 37 to 39 and runs 2 years. So it rises 2 cents, runs 2 years, or a 1 cent per year increase on average between 639 and 842. It rises 3 cents and runs, okay, let's make this bigger. It rises 3 cents and runs 2 years. Okay, so rises 3 cents, runs 2 years, or 1.5 cents. That should look familiar. We've done this on the front, right? And then the last 2 points here, we've got it's going to rise 4 cents. So it's our biggest overall increase value-wise, but it runs across 5 years. That makes things a little bit different. So let's go ahead and put that one in there. Again, we've done this. It rises 4 cents over 5 years, or 0.8 of a cent per year. Now here's the interesting part, right? We're looking at the slope, or the rate of change in this case, the average rate of change between these points. Between which 2 years is the rate of change, the change in postage per the change in year, the greatest? It is not the year, or it's not the between when it went up the most, because it took longer to do that. This slope, this rate of change is bigger between 2006 and 2008. Between 2006 and 2008. The reason being is 1.5 cents per year on average is bigger than 0.8 of a cent per year on average. Compare the line segment between 2006 and 8 with the line segment between 8 and 13, which is steeper. I mean, it's not perfectly drawn here, but this is definitely steeper than this line. This is the steepest line in there. So, which is steeper from 2006 to 2008? Which represents the greater rate of change? 2006 to 2008, right? That's our biggest rate of change. How do you think the steepness of the line between 2 points is related to the rate of change it represents? So the steeper the line indicates a larger rate of change. The steeper the line, the greater the rate of change. There we go. So the steeper the line, if I have a steeper line, I have a larger rate of change. If I'm comparing two lines or comparing two rates of change. All right? So again, if you need to, go ahead and pause this, take a look, write anything down that you want to. I'm going to go ahead and move to the next page. We have determining the slope of the line. Now, this is something that we've done many times. We're going to be more direct with it, and we're going to apply it a little bit differently. So the rate of change for a linear function can be calculated using the rise and run of the graph of the function. The rise, that's one of those bold words again, right? The rise is the difference in the y values on 2 points on a line, and the run is the difference in the x values of 2 points on a line. The slope is the ratio. Ratio means fraction. Just going to write that up there as a reminder. Ratio means fraction. It's the difference in the y values to be compared to the difference in the x values, right? So let's look at here. We've got this graph here. It says determine the slope of the line. 3, 4 is 1 point, 2, 1 is another point. So if I'm looking at the slope, I rise. This is one of those goofy graphs. The lines go by 2, right? So this goes up by 3. So it rises 3, and it runs 1. So rises 3, runs 1 for a slope of 3. Okay? Now, I'm going to kind of ignore this part here, right? We're going to do the rise and the run part. We've got -2, 3 is 1 point. Okay? And we've got 1, 0. Well, this is interesting because this goes downhill if I'm comparing the points here. This actually goes down 3. So down would be considered the negative direction. So it goes down 3, but it runs, let's see, 1, 2, 3 also. But it goes to the right 3. If I simplify negative 3 divided by positive 3, well, a negative divided by a positive is a negative. This is negative 1. The slope is negative 1. Okay? So now we got that business going on here. That's kind of interesting, right? Find the rise of a horizontal line. Let's draw a horizontal line real quick. If this is my horizontal line right here, what's the rise here? Well, you tell me 0. There is 0 rise. You tell me that there is 0 rise. In fact, this just keeps running. So it'd be like 0 divided by, what's that thing we call just never ends? We call that infinity. So it's 0 divided by infinity. It's that sideways 8, right? 0 on top dividing gives us a value of 0. For a vertical line, the slope of a vertical line, let's look. Go ahead and change the color real quick. Oops. This. There is my vertical line. This has all the rise. This has all the rise and no run. Find the run. It's 0 run. 0 run. So the slope, this would be all the rise. And we talked about all the rise being an infinite number. When we talked about run in the other one, this would be like infinity divided by no run. You see divided by 0. You cannot do that. If you find a way to do that, let me know. We can make a lot of money off that, all right? Because, there'd be important things we could do, but it's not possible. We call this as being undefined. That is an undefined slope, okay? And so if we look here, let's look what we got. This one, this graph right here, as I went left to right, that's going uphill, and that gave us a positive slope. Right? This next graph went downhill, and that turned out to be a negative slope. If you look at the graph of a horizontal line, we said that was a 0 slope. And the graph of a line of a vertical line, we called that an undefined slope. So that next question, how do you determine if it's positive, negative, 0, or undefined without looking or using points on the line? Look to see if which direction it goes. If you're looking left or right, if it goes uphill, it's a positive slope. Downhill is a negative slope. Horizontal is 0. Vertical is undefined. Well, we're going to make charts and stuff like that. What we got to. Don't worry about that. Okay. Let's look. Find the slope of each line. Find the slope of each line. All right. I'm just going to go through these real quick. Don't worry about these. I'll let you do some other ones later. Okay. So if I start here, I go from negative 3 to positive 3. So I've risen 6, and I run 5 to get there. So I rise. My rise is on top. I rise 6. I run 5. And that's it. Do not, please, do not turn that into a decimal. Do not turn that into a mixed number. Leave it as 6/5. 6/5 is perfect and it's beautiful. Leave it just like that. Simplify it if you can, but this can't be, right? It's also, we notice that this is going uphill, so we know it has to be positive. We know it's got to be positive, right? Let's look at the next one. Well, let's just kind of look at this one. It's going downhill. We know that whatever we do, this better be a negative slope because it's going downhill. Let's see, I start at positive 2. I go to negative 3. So I've gone down 5. Down 5. And I go from negative 3 to negative 2. So I go right 1, a positive 1. And negative divided by a positive is a negative. So that's good. We got our negative. And that 5 divided by 1, this becomes negative 5. Our slope is negative 5. Now, you're saying, Mr. Brayman, got all that. We're all good to go. Okay. Slope formula. The slope formula here. If you have 2 points on the line, this is a coordinate pair, x1, y1, and this coordinate pair, x2, y2. The slope of the line is m equals y2 minus y1 divided by x2 minus x1. Notice here. Those are both 2's and those are both 1s. You need to keep the 2s and the 1s in the same column, okay? Because I will go even a step further. If you've got these 2 points, because it doesn't tell you which point has to be which. It doesn't say x1, y1 has to be the left point, and x2, y2 has to be the right point. It doesn't say. This will also work. If you do y1 minus y2 divided by x1 minus x2, that will also work. Okay, so let's take a look at an example here. I've got this one here. I've got -2, -1, and 2, 3 are points on this line that define this line. So I'm going to do this. I'm going to treat this as my x1, y1. I'm going to treat this as my x2, y2. So if I'm using the slope formula of y2 minus y1, so m equals y2, that is 3, minus y1, that's -1. And on bottom I have x2, 2, minus x1, which is -2. What I end up with, well, minus a negative is plus a positive. So on top I get 4 divided by 2 minus a negative, still plus a positive. 4 divided by 4, that gives us a slope of 1. Double check it right there. We're good to go. All right. So what you guys can do is we've got this business going on right here. You've got another example, right? You can pick any point that you want on here, any 2 points, right? They've got all this stuff in here. I'm going to do what I want. I'm going to pick these 2 points. Remember, this is x and the y, and x and the y if we've got a table like this. So I'm going to pick the 2 points. I'm going to pick, we might as well pick the same ones they do. Why not? We could make this x1, y1, and x2, y2. So let's go ahead and subtract this. We know that slope is y2 minus y1 over x2 minus x1. y2 is 8. y1 is 6 divided by x2, which is 3, minus x1, which is 3. On top, I get 2. On bottom, I get 0. Take a second and think about it. When you divide by 0, you can't do that, first of all. We call that undefined, and that happens to be the type of slope this is. The slope is undefined. I'm going to shorthand UND, and when you have an undefined line, remember this is all rise with no run. All rise with no run. That is a vertical line. The line is vertical. That line is vertical. All right, so let's go one more step here. What I want you guys to do is try these out. So push pause on that and try these 2 out, then come back and it will be here and done. And I'm back. So graph shows a linear relationship. I'm going to use these 2 points here. I'm going to treat this, make that a little bigger so we can all see it. I'm going to treat -1, 9 as x1, y1. I'm going to treat this one, 2, -5, as x2, y2. And I'm going to use my slope. I'm going to say m equals y2 minus y1 over x2 minus x1. M, again, that's the letter we use for slope. Okay? And if you remember, think of y equals mx plus b. The m is what we're after here. So let's go ahead and do this. y2 we said is -5 minus y1 is 9 divided by x2, which is 2, minus x1, which is -1. So just be careful when you're doing your addition and subtraction. If I've got -5, so if I'm in a number line, I get -5, and I go 9 more negative, I'm going to end up at -14. And on bottom, minus a negative is plus a positive. 2 plus 1 is 3. Now, we're saying that this slope is negative. First of all, leave it like that. That's perfect. It's a beautiful number. We're saying that this slope is negative. Does it look negative? Is this going downhill, left to right? It sure is. So our work matches our slope. That's awesome. Okay, let's look when we've got a couple tables of things. Oh, we got a goofy one here. It's all the same numbers. Remember, these sets across the top are the x's, and these are the y's that are associated with them. I'm going to take, why not, these 2 points right in here. I'm going to call this x1, y1, and x2, y2. Use your formula again. M equals y2 minus y1 over x2 minus x1. My y2 is 5, minus my y1, which is also 5, divided by x2, which is 3, minus x1, which is 2. On top, 5 minus 5, I do believe, is 0. 3 minus 2 is 1. And 0 on top divided by anything on bottom is 0. This is a 0 slope. In other words, we have no rise, but all run. All run. We call that a horizontal line. This is going to be a horizontal line if you're not sure. So this slope is 0. Okay, here's what I want you guys to do. I'm going to hit pause on this one. That's part 1 of the video. We'll do the interpreting the next part of the video. What I want you guys to do is the practice, and I'm going to, let's see here, practice 1 through 6, starting on page 227. Also do 7 through 12. And let's just go with those for now. Actually, there's one more I want you guys to do. 18. 18. So basically 1 through 12 and 18 is what I want you to do for part 1 of this video. Yeah, so that's what I got for you right now. We'll do part 2 of the video later, and hope you guys have a great day. Take care.